everybody! So, fire extinguishers. They're one of those funny things that have been around for centuries. Actually, ancient civilizations had them probably since they moved into cities and had fire and a morbid fear of burning the whole city down. But they are one of those things that have been there so long that they kind of blend into the background and we don't really notice them, which is probably why we have to have fire drills to point out that they're there. But they are just everywhere. There's loads of them, and of course once they've been used or they've gone out of date, they pile up and nobody really knows what to do with them.
Early civilizations grappled with the destructive power of fire, recognizing both its utility and its danger. The ancient Greeks utilised a rudimentary form of firefighting around 200 BC with hand pumps to douse flames. However, it wasn't until the 17th century that significant strides in fire suppression technology began to emerge. In 1666, the Great Fire of London ravaged the city, prompting the development of more sophisticated firefighting tools. English chemist Ambrose Godfrey created a primitive fire extinguisher using a pewter chamber filled with potassium carbonate solution. When activated, this device expelled the solution through a compressed air mechanism, effectively smothering the flames. The 18th century witnessed further innovations. In 1723, the first fire insurance company, the Union Fire Office, was established in England. These insurers recognised the need for better fire prevention and suppression methods to protect their investments, leading to improved firefighting equipment. Throughout the 19th century, various inventors contributed to the evolution of the fire extinguisher. In 1818, Captain George William Manby painted a portable fire extinguisher capable of projecting an extinguishing agent through a nozzle. He used a mixture of water and potassium carbonate to combat fires. This marked a significant leap forward in firefighting technology. The mid-1800s saw the introduction of the soda acid extinguisher. This device combined water and sodium bicarbonate with sulfuric acid, generating carbon dioxide to extinguish fires. It was a pivotal development, although its use was limited due to the corrosive nature of the chemicals involved. Further advancements occurred in the 20th century with the invention of the carbon tetrachloride extinguisher. This innovation provided an effective means of combating electrical fires. However, its toxic and environmentally harmful nature led to its eventual phasing out. The mid-20th century witnessed the rise of the modern fire extinguisher. Innovations such as dry chemical extinguishers, which utilised powder agents like sodium bicarbonate or potassium bicarbonate, gained popularity due to their effectiveness against various types of fire and their non-toxic nature. Advances in technology continued, leading to the development of specialised extinguishers tailored for specific fire classes, including Class A, ordinary combustibles like wood and paper, Class B, flammable liquids, Class C, electrical fires, and Class K, cooking oils and fats. Moreover, the introduction of pressurized canisters and the use of non-toxic environmentally friendly agents like halon alternatives and clean agents marked a significant shift towards more efficient and safer fire suppression methods. As concerns about environmental impact and safety grew, further research and innovation focused on creating fire extinguishers that were both effective and eco-friendly, and this led to the emergence of extinguishers using inert gases and foam-based agents which are non-toxic and don't harm the ozone layer. Of course, recently, smart fire extinguishers have emerged with sensors and IoT capabilities enabling early fire detection and automated firefighting processes.
So quite important things, and I think quite an interesting history, but of course they do come to the end of their life and they get decommissioned, and they're a really useful supply of some very nice steel.
Okay, so these things, because of the way they make them, are actually a bit of a pain. They put the whole thing together, fill it with powder, put the valve on, and then pressurise it. This is pressurised with nitrogen, and there's no way to depressurise it without discharging it. And of course that means it sends the powder everywhere, because of course the powder is supposed to go everywhere. It's a fire extinguisher. So the only thing you can do when discharging these is mitigate against the powder spread. Comes out at pressure, so it shoots a fair way. What I've got here is a big plastic box with a hole in it right there that I'm going to point the fire extinguisher in. And then the reverse there, I've cut a hole, put a bit of cloth out on it to act as a kind of filter, and then a few weights on the lid to keep the lid on. But it does still fly everywhere. So obviously I've covered this here. Now you capture the bulk of it, but a little bit of it is going to escape, and that makes it a little bit of a pain. So you should do what I'm not doing, and that is wear a mask. Anyway, once you get it set up, stick it in the hole in your big box and squeeze the handle. And of course the little bits do come out, which is why you should wear a mask, and don't squeeze it and hold it. Okay, so it's been discharged. You will notice, incidentally, I do have my mask on. It's a HEPA filter mask because this is a light dust. But you end up with a discharge fire extinguisher and a box full of this stuff. This stuff is actually ammonium phosphate and ammonium sulfate. It's been sphericalized and silicon coated, but that's what it is, and they're both fertilizers, incidentally. Now the ratio will change depending on your country, so sometimes it's 40-60, sometimes 60-40, and here in the UK it's 90% ammonium phosphate and 10% ammonium sulfate, and that's what we've got here. Now when we discharge this, all the pressure is gone, so it's safe to remove the valve, but it's still half full of powder, so all of the powder doesn't come out. So what we need to do is remove the valve. Now, I don't really care about this, I'm never going to use it again, so lay it flat, and there on the valve component, right there, just give it a whack. And you'll get it loose enough to undo it by hand. As I say, remember, there is still powder in here, just no pressure. There we go. Now we've got a little bit of steel, bit of rubber, bit of plastic, but we still have that brass. So you could separate this brass out, collect them and weigh them in. And now we can empty the rest of the powder out of this. So that dry powder, it's clearly a pain, hey? Now the main strategy is containment, which is why we discharge them into that box, because here in the UK, the dry powder is considered biodegradable. So as long as you put it in a sealed container and you don't have several tons of it, you can dispose of it in landfill. I'm guessing if you're doing a lot of these, then you need to contact a specialist disposal firm to dispose of the chemical. But if you're doing one, like you've had to discharge it in your house, or you want to empty out one of them, then seal it up and stick it in your bin, and it's considered biodegradable. That may change depending on where you are in the world, but certainly that's the case here in the UK. Now it is mildly, and I mean mildly, corrosive. It's mildly acidic. If you're worried about that, then on that final powder cleanup for the stuff that you can't contain, and there isn't much, but it does get everywhere, then you can wash it down with a bit of sodium bicarbonate if you want. Soapy water and a rag is also recommended for cleaning up that last little bit of dust. Now, of course, I want to do something with them. Doing something with them means really just cutting off the top. Now, it's got a line here, so I guess I could just cut it freehand. But as I want to cut off the top and the bottom, and I've got 4 of them, I thought some kind of jig would be nice. Because remember, I've also got to do a gas canister, and I'd like a nice straight line. Now, it's not that difficult to get a straight line. We've done something very similar with the lathe. What we're going to do is use 4 of these things, casters. Now, I'm going to fix them to the bench, because I've got a big old solid wooden bench. If you don't, then a plank of wood's going to do it just as well. And all we really do is screw those in at the correct distance. That will then rest on there and be able to turn, and we put a block in there and it's going to turn in one line. So let's do that bit first. So there's my caster wheels just set there, and they're set far enough apart and with enough distance that this will fit on it. Got an L-shaped bracket of wood that I put there, so the fire extinguisher basically sits like that. It can't go that way because of this, and it will turn nicely on the casters as I turn it. So what I need here is a cutting head, and of course we're going to use the angle grinder. So I need to fit the angle grinder so that it will be in that position. Then as I turn the angle grinder on, I can spin that and it will cut it. Now to fix that, all I'm really going to use is a block of wood on there, and then some hose clips to fasten it down. Okay, so I mean, this is so simple it's almost embarrassing, hey? All I've done is hose clip the angle grinder to a block of wood and stuck a hinge on the bottom. Now all I've got to do is just line that up a little bit. That'll do it. And then screw that down to the bench. Okay, now I'm ready to give it a go. Okay, that worked awesomely. Talk about a super simple setup. It did a beautiful straight cut. You can tell just because how that balances on there so nicely. So there we go. Cutting really stupid large metal pipe, nice and square with a simple jig. Clearly, you can adapt that jig by moving those out a little bit, those casters out a little bit, moving the block backwards and forwards, going to be able to adjust it a little bit, and then you'll be able to cut any size pipe, including those gas canisters, to a square finish cut, which is really cool. I want these because I want to make a vortex rocket stove out of them, and I don't want to pay 90 quid for the pipe, such is why I wanted these. And once you cut the top and the bottom off, what you're left with, of course, is a piece of pipe. Now this is a 150mm or 6-inch piece of pipe, and I'm going to want to join that at some time or other to other bits of pipe. Now joining them straight on is dead easy. We've got a nice square cut, but if we want to join them at 90 degrees, we need to notch that out. And I came across this super simple trick for notching, which I thought I would share with you. All you do is stick your bit of pipe on a bit of paper and draw around it. And give you a nice circle, cut that circle out. Once you've cut it out, fold it in half. And we have ourselves a centre line. Measure that centre line, which for me is 150, no surprise, it's what I said that was, and divide it into 3, so 5 and 5. Then we can fold that along the line there at the mark and line up the two centres, and we get a third. Now we want to transfer that to our pipe, lay it on the pipe and transfer the centre marks. Now cut off your third. Then we put the centre to the centre, draw around it, same the other side. There we go, now we're ready to cut that out. So when you've done that, of course, round off these edges and pretty up the sharp edges with your grinder. Okay, you can see where I've rounded out the corners there, which I did by eye, to be honest, and if we slot that on there, there you go. Now the rest of it's really easy, obviously. You just draw around what you've just done. Leave about 1/2 centimetre and draw around it again. And then cut out that section with the 1/2 centimetre and we're ready to weld. So there we go. And what surprises me is how good a fit it actually is. There is an extremely easy method to notch out a pipe. Now you can draw up a template, of course, and a template is going to be much more accurate, of course, but That gap is enough to be able to fill with weld metal, and it works really well and really quickly for getting you a pipe that's at 90 degrees and notched into another. We made a cutting jig using casters, and it made just about every job on a pipe easier. Cutting it, grinding it, finishing it, all that sort of stuff. It was so much easier just to lay the pipe in the rollers and turn it round. Then Luke had an idea, and I thought, this is actually a bit of genius thinking. Now we have a MIG welder, and these MIGs have a tiny little wire there, and if you press the button you get a wire feeding out. So theory, if we hold that at the right distance and we let the wire feed out and turn it, it should weld really easily, because welding around pipes is a real pain in the neck. But if all I've got to do is hold it and turn it, we should have a super easy job. So I've set up 2 sets of 4 so that the pipe can go there, and just want to make sure it's the right way around. Yeah, the pipe goes there. Because these fire extinguishers, of course, what I want them for is a chimney for a rocket stove, which means I've got to join them together. Now they're 33 centimetres long each, so I want 3 of them, making me roughly a metre. Now, obviously if I turn that one won't turn. So what I need to do, I think, is put a couple of spot welds to hold it in place, and then give it a go with the MIG welder and see if we can actually do that. Okay, there's the 4 spot welds on, so let's give the MIG a go. Okay, that's it. Oh, there's no light showing through, so there's no holes. Now, definitely made it easier, hey? So, clever suggestion from Luke. He's a smart boy, that boy. So, how to weld up really easily to make lengths of pipe using the jig. Anyway, hope you enjoyed the video. Thank you very much for watching, and please remember to like and subscribe.